You guys did it, but I didn't actually.
We just hadn't plugged in the final numbers to get.
Oh no, we were like done.
We actually went through it?
Yeah.
Okay, good. All right, so now we'll move on, okay? All right. We're going to work on a couple of other things. We need to do some more work on forces. Okay. Here's an example. We're going to deal with this, all right? If I have, let's say, all right, obviously we have the Tasmanian crate, right? Because we can't not have Tasmanian crate, right? Except this time the Tasmanian crate, okay, because it's from Tasmania, right? All right, except this time the Tasmanian crate is in space. Tasmanian crate is in space. Okay? Because it's the inverse, because it's easier to paint black on white versus it's a negative picture of space. Okay, so I've got a rope. The Tasmanian crate is obviously pulled by a rope, right? All right, let's do it this way. Let's actually we're gonna have a rope here and a rope here. Okay? And what is pulling that rope in space? Everybody? Spaceship! And aliens. Okay, so we've got the spaceship. So did someone just laugh at me about my... Come on now, this is so cool. Here we go. UFO. All right. And we've got another one of these guys. There's two spaceships. Okay. Okay. All right. Okay. Now, okay. All right, kiddos, you're getting. All right, Harrison, you getting it done? You got to change the spool out, Michael.
Yeah.
Okay. All right. So here's the deal. Shh. So here's the deal. The mass of the crate. Okay, is going to be 20 kilograms. Okay. The force of Spaceship 1 is 120 newtons. And the force of Spaceship 2 is 80 newtons. The angles are different, even though they look exactly the same. This one is 30 degrees, and this one is, call it 50 degrees. Okay?
What was the force of Spaceship 2?
Force of Spaceship 2 is 80 degrees. 80 newtons, excuse me, 80 newtons. Okay? What I'd like you to tell me is the net force, okay, that the object receives, okay, and I'd like you to tell me the acceleration, the net acceleration and direction from this force, of the net acceleration and direction of the crate. Does that make sense?
Sure.
All right, go. So let's figure out how to do this problem. Let's do this problem. Okay, I'm going to shrink down the image so we can. Can you guys see that still? I'm just trying to have enough space to do the work while you can still see what's going on. Okay? All right. So what is our overall strategy? What are we trying to do? At the end of the day, what are we trying to figure out?
Find the net force.
The net force in what directions?
Vertical and horizontal.
Vertical and horizontal, because from those two things we can determine what? The final force vector, and therefore the final acceleration vector, right? So we're looking for the sum of the x's and the sum of the y's, right? But we have these two forces that are not in the x and the y alone, are they? They're at an angle. So what do we have to do? Break it down. So the first thing we do is what? What's the first thing we do?
FDG.
free body diagram. So we draw a free, oops, let me come back here. Draw a free body diagram. Okay? Now, what are my forces? What are my forces going to be on this free body? What are my forces?
FS1X, FS1Y, FS1.
Okay, hold on. FS1X,
FS2X, you want to do.
FS2X. Is this the right direction for those vectors?
Yes.
Okay, because they're pulling to the right. What else do I have? FS1Y and FS2Y. Notice they're going opposite directions. Now look, listen up. I know that I said, technically you can put these vectors anywhere you want. Technically, yes. I would like you to do it as intuitively as possible. Okay? It's going to help you. It's going to help me. I just gave you the caveat that technically it can go anywhere if you're running out of space. But do it as much as you can. Do it as intuitively as possible. Do you guys see that? It's going to help you understand the problem better. Make sense? Yes? Okay. So everyone has a free body diagram that looks like this. This is correct. Okay. So let's write the equations. Let's not do any calculations. Let's write the equations. What are my equations that I want to write? But wait a minute. Why is gravity and the normal force not in here? Because it's in space, there's no gravity. And why is there no normal force? It's not pushing it on anything, right? So nothing's pushing back. Okay? So what are the two equations, the two summation equations I need?
F of the force and the Y,
Okay.
and the force and the X.
And the sum of the forces in the x. What are the sum of the forces in the y? Give me those two forces. In FS1y and FS2y. Now remember, notice that FS2y is pointing down. Notice I didn't take the negative into account just yet. Okay, I'm just summing up my values. Okay, what's the summation of the forces in the x? Okay, now, so I now need to figure out, I cannot go any further at this point because I don't know that they equal 0, do I? Why would I ever say this equals 0? What would be, Well, that's one option. Okay, but let's talk about the motion. What would I have to know about the motion? What would the motion have to be?
Velocity or 0.
Okay, a constant velocity of either a positive or negative number or 0. A constant velocity of some number or 0. As long as it's constant velocity, that means my acceleration is what? 0. If my acceleration is 0, what does that mean about my force? 0. Okay. The only way you know to set this equal to 0 is that it is, hey, you got it off. Good, Harrison. Good. The only way you know it's equal to 0 is, number 1, the motion is 0, okay? Or 2, you assume the motion is 0, okay? Because you're trying to find out. Or the acceleration is 0, excuse me. The acceleration is 0, not the motion. Okay, so we need, at this point in the game, we've got to figure out, this is going to equal some sort of net force, right? Some sort of net force in the y and the x. Okay, so I got to figure out values. How do I figure out the value for FS1, x, and y? Trig, right? So I've got my triangle, and I'm going to say, okay, well, right? So I've got my FS1x and my FS1y, right? Okay? So that means that FS1y equals my FS1 times the sine of 30 degrees, right? Okay? And you can even go as far as saying 120 newtons times that. That's enough work, okay, for trig stuff. Okay, I want to see this work right here on the exam with variables. Okay, we're going to have an assessment, some sort of assessment next week. I think it's going to be like a group problem set. That'll be a quiz grade, and then the following week we'll have a test. Okay, so be prepared for that.
Wait, so the week after that is a test?
Yeah. Okay, so that means FS1Y is equal to what? What's sine of 30? 1/2. So what? 30 times 120 is 60 newtons. Is it positive or negative? Positive, because it's going up, right? Fs1x is equal to 120 times what? The cosine of 30 degrees. So Fs1x equals,
It's like 3.3.
yeah, 103.9. Let's call it an even 104 newtons. Okay? All right? Okay. Positive or negative? Positive. Okay. Now, Fs2x, Fs2y. Okay? So Fs2x equals what? Or excuse me, Fs2y equals what? Fs2y equals what, guys? Give me an equation.
61.2.
Well, don't just give me an answer. You've got to show me a little bit of math of how you get there. Okay, 80 newtons times sine 50. That's enough for the SOHCAHTOA to get. I don't need you to show me all of the sine of theta equals opposite over. You can just show me that, but I've got to see where the number comes from, okay? Otherwise, I can't give you partial credit. Let's say you made a mistake and you said sine versus cosine. Oops, okay. All right. So, Fs2y is equal to what? What's the value now? How much? What is it?
Fs2y.
What's the value? How much? Negative 61.3 newtons. Why is it negative? Because it's going down. Be sure you're there. Okay. Fs2x is equal to what? 80 newtons times what? Cosine of 50, excuse me. So Fs2x equals what? 51.4 newtons. And is it positive or negative? Positive. Okay. Now I can plug my numbers back in, can't I? And start to solve for start to solve that equation. So now I can say the sum of the forces in the y equals, what's my Fs1y? So positive 60 newtons plus, what's my Fs2y? Negative 61.3 newtons, okay? Okay, that means my total is what? Negative 1.3 newtons in the y direction, right?
But like 1.28, like
That's fine.
I just like pointed it down.
You got to use your sign. Got to use your sign. The signs are telling me and telling you what direction they're going to go. Don't point up and down. Put the sign. Okay? Because at this point, when you're in the math, here's the thing, David. If you're in the math and you don't do that, you're going to miss an arrow, and you're going to add a number when you really should subtract it. Does that make sense?
Yeah.
Okay. So the sum of the forces in the x, what's Fs1x value? 104 newtons plus 51.4 newtons. So that the total force in the x is 155.4 what? Oops. 0.4 newtons. Okay. So that gives me, so I can actually redraw this, if I wanted to, redraw a free body diagram where I now have my Fx net equaling what? 155.4 newtons. And I have my Fy net equaling what? Negative 1.3 newtons. You guys see that? So I've now boiled this down to a summation of two basic vectors. Do you guys see that? And from that, visually you can see what direction's the crate going. down to the right. Let's figure out more precisely than just down to the right, because that's not going to get you credit. Okay, so I'm going to delete this stuff up here. Is that cool? I'm going to delete this. You guys good?
Yeah.
Going once, twice, gone. Okay. I'm going to delete this stuff here. Yada, yada. Delete this stuff. Too late. Was it really or no? David, really? I can go back.
No, I don't need
Control Z.
no.
All right. So we've got this. How do I determine my final net force? What is it? Let's draw the triangle, right? I've got this force of Fx net, and I have this force of Fy net. I'm gonna get a final force vector. It's my F net, right? At a specific angle. Everyone with me? Okay, this shouldn't be too hard, right? So how do I figure out the magnitude of F net? F net magnitude is equal to what?
Reverse
Oh, yeah.
The net, I could also do Pythagorean theorem, right? Right, I could just do Fx net squared plus Fy net squared, and I could square root that, right? So the F net value, the magnitude, is equal to what?
So just for the record, we can use the Pythagorean.
Yes, guys, you can always use the
You
Pythagorean.
told us not to.
Okay, I told you once for one assignment. I said for this one assignment, I wanted you to practice Craig. And then I never said it again. And I wrote it on the assignment. I never wrote it again. So you can always use the Pythagorean theorem. 155.4 squared plus 1.3 squared equals square root is what? 155.4 essentially. 155.4. Okay? What's the angle that we're going at? What's the angle that we're going at? How do we figure the angle? Okay, so the inverse tangent of what items? Fy net over Fx net, right? And that's going to equal my theta. So theta equals the Fy net, which is 1.3 negative, right? Divided by my Fx net, which is 155.4. And I'm going to say inverse tangent, it's barely a half a degree. It's about a half degree, so it's 0.5. Yes, because when I ask you for the vector, it's magnitude and direction. Okay, and it's down. And it's down. You guys see that? The half a degree doesn't matter now, but 10 light years from now, it's from there, it's going to matter.